Hello everyone, welcome back to the Microservice Masterclass. In our previous video, we learned about the domain driven design and discovered that software should be designed around the business capabilities, not around the databases or UI screens. But that have one important questions. How do we decide what should become a microservice? Let's take an example. Should I design a payment or order service together, or should I design both of them separately? Should inventory be separate? Should notification be part of the order? How small should a microservice actually be? These are the questions every software architect must answer, and that's what exactly we will learn today. By the end of this lesson, you will understand what service design is, what service boundaries are, why they matter, single responsibilities principle, high cohesion, loose coupling, how companies like Amazon and Netflix design their services. So let's begin. Let's start the very first section of our diagram. You can see a simple flow diagram. We have a business requirement, then what should become a microservice, then service design, then correct service boundaries, then scalable architecture. Now think about this. Imagine your manager comes to you and says, "We want to build an online shopping application." That sounds simple, right? But immediately many questions appears. Should user and order be one service? Should payment have its own database? Should inventory be inside order? Should shipping be separate? These are not coding questions. These are design questions. and if we and if we make a wrong and if we make a wrong decision today, we will suffer for years. This is this is why service design is one of the most important skills for a software architect. It is its goal is simple. Design service that are easy to maintain, easy to deploy, easy to scale, easy to easy for teams to own, independent independent from each other. Good service design reduce the complexity. Simple. Bad service design create the technical doubts. Let's take a real world example. Imagine a hospital. Would one doctor perform surgery, manage billing, clean rooms, operate the pharmacy, drive the ambulance? Of course not, right? Every department has a clear responsibility. Hospital work because responsibilities are clearly divided. Microservices follow exactly the same principle. Correct? Now let's move to the next part. What is a service boundary? Now let's first look at the wrong design. Imagine we create one giant order service. Inside we place user, product, payment, inventory, shipping, notifications, right? Everything inside one service. At first this looks convenient. Only one project, one deployment, one database. But after some time, maybe 6 months or one later down the line, problem begins. The code base became huge. Different teams modify the same code base. Deployment became risky. A small payment changes requires redeploying the entire application. Inventory bugs. Inventory bugs affect the order processing. If some issue comes in inventory service, inventory side, it will affect the order processing. Notification failure impact payments. Soon everything becomes tightly coupled. Now look at the correct design. Instead of one giant service, we divided the application into business capabilities. We created user service, product service, inventory service, order service, payment service, shipping service, and notification service. Each service has its own database, its own API, its own deployment, and its own development team. Now, teams can work independently, right? If the payment team wants to deploy a new feature, they don't need permission from inventory team. As simple. This is the power of well-defined service boundaries. Let's take one real-world example. Think about the Amazon. When we place an order, many departments work together. The warehouse checks inventory, the payment gateway process your card, the delivery partner prepares shipping, notification system sends confirmation details. These departments communicate with each other, but each department performs its own job. That's exactly how microservices should work, right? Now let's move to the next topic, next point. Single responsibility principle. This principle says one service should have one region to change. As simple. One service should have one region to change. Let's understand with one example. Imagine we create a payment service. Sorry. Inside it, we add payment, refund, discount, inventory, shipping, email, invoice. Now ask yourself, what exactly this service is responsible for? The answer is everything. And that's the problem. Now imagine the marketing team wants change the discount. The logistic team changes shipping. The finance team updates the invoices. Everyone modify the same services, right? Deployments became dangerous. Now compare it with the good design. Let's compare it with a good design. Payment service contains only payment and refund. That's it. Notification service contains email, SMS, and push notification. Right? Each service focus on one responsibility. That's much easier to understand, easier to test, easier to maintain even, and much easier to scale. Think about a restaurant. A cashier handles payment, a waiter serves customers. Imagine asking the imagine asking the imagine asking the chef to cook food, collect payments, clean table, and answer the phone calls, and also deliver the food. Soon everything breaks, right? One person cannot do everything. Same way the software works. So one service should have one responsibility principle, single responsibility principle. Now let's come to the next point, high cohesion. Cohesion simply means how closely related to the how closely related the principle is, how closely related the responsibility inside a service are. Let's compare two examples. First, high cohesion. Inside the order service, we have create, cancel, update, track, order, order history, right? Notice something. Everything is related to the order. That's high cohesion. Now looks now let's look at the second example. Inside the order service, we suddenly push the employee payroll, generate salary, product search, email, weather API, right? This is low cohesion because these have nothing to do with orders. Low cohesion makes software difficult to understand. Testing became harder, developers became confused. Maintain, Maintenance cost increases. A high cohesive service is focused. It has one clear purpose. Imagine, imagine your wardrobe. If one shelf contains only shirt, another contains only shoes, and another shelf contains only the documents, you will find everything easily. Correct? Now imagine every shelf contains clothes, books, chargers, shoes, medicines, groceries mixed together. Finding everything becomes frustrating, right? That's the difference between high cohesion and low cohesion. High cohesion is always good for the service design. Now let's move to the next topic, loose coupling. On the left side of the infographic, we see a bad example. The order service directly access payment database, inventory database, user database, shipping database, notification database. These creates the tight coupling. Now imagine the payment team changes their database schema. Suddenly the order service breaks, right? Inventory may also break, reports may stop working. One small change, one small database change affect the whole system. This is exactly this is extremely this is extremely dangerous. Now look at the good design. The order service never access another service database. Instead, it calls the payment service through an API or publish an event. The payment service owns its database. Inventory owns its own database. Shipping owns its own database. Every service is independent. This allows each team to modify their database without affecting others. This is loose coupling. So, tight coupling and loose coupling, which one is the better? Loose coupling is the always better for the design. Correct? If you see the real world example, imagine you want to order food. Do you want do you walk into the restaurant kitchen and start cooking? Of course not, right? You talk to you talk to the waiter. The waiter communicates to the kitchen, and the kitchen prepares the food. The cashier handles the payment. Departments communicates through the well-defined interfaces. Microservices should do exactly the same. Okay. Now let's move to the next part. Design checklist. A good microservice should have one business capability, one team ownership, one database, one API, independent deployment, independent scaling, high cohesion, loose coupling, stateless design, and fault isolation. Whenever you design a new service, ask yourself these questions. If most answers are yes, you are probably designing a good microservice. Okay, let's summarize the architecture. Look at the final architecture at the bottom. Clients such as it has the clients such as web app, mobile app, admin portal. Send request to the API gateway, right? And the API gateway routes request to the different services, right? Every service has its own database, its own API, its own team, its own deployment pipeline. This architecture allows companies like Amazon, Netflix, Uber, and Spotify to scale individual part of their systems independently while keeping teams autonomous. Okay, let's quickly recap today's lesson. We have learned why service design is critical before writing a code. We explored how to define service boundaries based on the business capabilities. We saw why each service should follow the single responsibility principle. We understand the importance of high cohesion and loose coupling. And finally, we reviewed the architecture checklist for designing a scalable and maintainable microservice. These principles form the foundation of every successful microservice architecture. If you get these right, the rest of the ecosystem, communication, deployment, scaling, and resilience become much easier to design. In the next video, we will dive into the service granularity, where we will answer one of the most common architect question: how small should a microservice really be? We have explored we have ex- we will explore fine grained versus coarse grained service, the trade-off of each approach, and practical guidelines for choosing the right size. If you found this lesson helpful, please like, share, and subscribe. Thanks for watching. I will see you in the next class. Thank you so much.